Hi, my name is Norhan and this is my 476 presentation, and my pattern is Composite Pattern, also known as Object Tree. Intent. Composite is a structural design pattern that lets you compose objects into tree structures and then work with these structures as if they were individual objects. Applicability. Use the composite pattern when you have to implement a tree-like object structure. The composite pattern provides you with two basic element types that share a common interface: simple leaves and complex containers. A container can be composed of both leaves and other containers. This lets you construct a nested recursive object structure that resembles a tree. Use the pattern when you want the client code to treat both simple and complex elements uniformly. All elements defined by the composite pattern share a common interface. Using this interface, the client doesn't have to worry about the concrete class of the objects it works with. Motivation and implementation. Motivation. A composite is an object designed as a composition of one or more similar objects, components, all exhibiting similar functionality. The key concept is that you can manipulate a single instance of the object just as you would a group of them. The composite pattern is useful in designing a common interface for both individual and composite components so that the client programs can view both the individual components and groups of components uniformly. Implementation, I put it into 4 simple steps. Step 1, create interface. Step 2, creating leaf class. Step 3, creating composite class. And then step 4, the client program. Participants. The first participant is the component, the drawing element. It declares the interface for objects in the composition. It implements default behavior for the interface common to all classes as appropriate. It declares an interface for accessing and managing its child components. And optional, it defines an interface for accessing a component's parent in the recursive structure and implements it if that's appropriate. Participant 2, the leaf. It represents leaf objects in the composition. A leaf has no children. It defines behavior for primitive objects in the composition. The third participant, the composite, it defines behavior for components having children. It stores child components. It implements child-related operations in the component interface. And then the last participant is the client, and it manipulates objects in the composition through the component interface. Reason and consequences. It defines class hierarchies. Simple clients. It doesn't care whether dealing with leaf or composite class. Uniform treatment of composite individual object, and it's easier to add new components. Consequences is new composites or leaves work automatically. They can make design over general. Sometimes want a composite to have only certain components, and it needs runtime checks. So here's a little diagram of the structure, and then here is the explanation of the structure. So the component interface describes operations that are common to both simple and complex elements of the tree. The leaf is a basic element of a tree that doesn't have sub-elements. Usually leaf components end up doing most of the real work since they don't have anyone to delegate the work to. The container is an element that has sub-elements, leaves, or other containers. A container doesn't know the concrete classes of its children. It works with all the sub-elements only via the component interface. And upon receiving a request, a container delegates the work to its sub-elements, processes intermediate results, and then returns the final result to the client. And finally, the client works with all the elements through the component interface. As a result, the client can work in the same way with both simple or complex elements of the tree. Relations with other patterns. You can use Builder when creating complex composite trees because you can program its construction steps to work recursively. Chain of responsibility is often used in conjunction with composite. In this case, when a leaf component gets a request, it may pass through the chain of all of the parent components down to the root of the object tree. You can use iterators to traverse composite trees. You can use Visitor to execute an operation over an entire composite tree. You can implement shared leaf nodes of the composite tree as flyweights to save some RAM. Composite and decorator have similar structure diagrams since both rely on recursive composition to organize an open-ended number of objects, and designs that make heavy use of composite and decorator can often benefit from using prototype. Applying the pattern lets you clone complex structures instead of reconstructing them from scratch. These are my references, and now I'm going to do the demo. So here we have a quick demo code, and here I have the comments explaining everything in the code and how it works and explaining the component. So I'm going to, I meant to say the composite design pattern. It explains all that, but I have it written down here, so I'm just going to go through that, and then I'm going to run the code and show you the output. So this code demonstrates the composite design pattern, which is a structural pattern that allows you to treat individual objects and groups of objects in the same way. It composes objects into tree-like structures to represent part-whole hierarchies. The pattern allows you to create a single abstraction for both individual objects and composition of objects. So in my example, the component class is an abstract class that defines the common interface for both leaf and composite classes. Leaf represents a single object, while composite represents a collection of objects. Composite has a collection of children that can be either leaf or another composite. The composite class implements the add, remove, and get child methods, which allows you to add, remove, and access child components. The operation method is also implemented in composite, which iterates over all the children and calls their operation method. In the main function, we create an instance of leaf and two instances of composite. We then add the leaf and the second composite to the first composite using the add method. We call the operation method on the first composite, which calls the operation method on all its children. Next, we remove the leaf from the first composite using the remove method. We call the operation method on the first composite again, which only calls the operation method on the second composite since the leaf was removed. Finally, we delete all the objects to avoid memory leaks. So here I've already run the code, and you can see that it gives me the output that I wanted and that we expected, but I will run it once more. And the only problems is just a warning for my override, and that's no issue. As we can see here again, it gives us the same output that we are looking for. So that was my presentation on composite design pattern. Thank you.